Length, area and volume represent numbers of dimensions. A length is a one-dimensional quantity. An area has 2 dimensions. And a volume has 3 dimensions. Have a think about this question. Can you add a length to an area? Does that make sense? With a little bit of thought, you should notice that it doesn't really, because we don't know what units the answer would be. So if you imagine a length and an area, you don't really know what units the answer is going to have. So we can't answer that question. The point is that centimetres plus centimetres squared is not going to be centimetres cubed. So we can't add together quantities with different units. However, we can multiply units. Think about how you'd work out the volumes of these shapes. If you had this rectangle, to find the area, you would do length times width. To work out the area of the triangle, you would do half base times height, or base times height over 2. And to find the area of the circle, you would do pi r squared, which is really just pi times r times r. And if you notice, in each case, you've got a length times a length, and that gives you an area. And in fact, that is a general rule. We should notice that length times length is area, and also that number times area is area, because we had pi times r squared, so r squared is an area, pi times r squared was still an area, it was the area of a circle. Think about how you'd work out the volume of this shape. This is a cuboid, so you'd work out the volume by doing length times width times height. So we know now that if we times 3 lengths together, you get a volume. Let's summarize what we've learned. So we need to know these for the exam. If I have a number plus a length, that isn't allowed. Think of 2 centimeters plus 4. Is that going to be 6 centimeters? No, it's not allowed because the units are different. There's one unit here, and there's one thing which is not measured with units. A length plus a length does make sense. It's just going to be a bigger length. A number plus an area, think about if that makes sense or not. No, that doesn't make sense. That's not allowed. An area plus an area, that does make sense. 4 centimeters squared plus 5 centimeters squared is 9 centimeters squared. A number plus a volume. We should notice by now that that's not going to make sense. A volume plus a volume does make sense. We just get a bigger volume. A length plus an area. We established earlier that doesn't make sense because we wouldn't know what units to give the answer. A length plus a volume, similarly, that is not allowed. An area plus a volume is not allowed. And this is our summary. So it should be obvious to us that the only time we can add units is if they're exactly the same units. Multiplying units, however, if you have a number times a length, that just gives you a length. A number times an area gives you an area. Think about pi r squared, that just gives us the area of a circle. Number times a volume still gives us a volume. A length times a length. Think about those formulae that we worked out earlier. Length times width is going to be area, so length times a length is an area. Think about what happens to the units. You've got centimetres times centimetres, and that's got to give you centimetres squared, which are the units of area. Length times a length times a length is going to be a volume, because you've got centimetres times centimetres times centimetres, centimetres cubed. A length times an area, think again about the units. Centimetres times centimetres squared is going to be centimetres cubed. So that's going to give us a volume. And the opposite holds true as well. So area divided by length is length, because centimetres squared divided by centimetres gives you centimetres. A volume divided by a number is a volume, because if you times by a number, you keep the units the same with dividing. Volume divided by length, think about centimetres cubed divided by centimetres. We end up with centimetres squared, and volume divided by area is a length. Here's a question to try. A and B represent lengths. State whether A times B squared represents in length, area, volume, or none of these. To do this question, I like to think about the units involved. So you could think about it like this, that we have a length times length squared, which is length times length times length, which is a volume. But what I like to think of is that you've got A, you could measure in centimetres because it's a length. B is measured in centimetres, so B squared is centimetres squared. Centimetres times centimetres squared is centimetres cubed, which would be a volume. So it does make sense, and it's a volume. Think about this question. Letters A, B, and C all represent lengths. State whether the formula represents a length, area, volume, or none of these. Well, to do this question, let's look at the individual parts of the formula. If C is a length, then 4C is a bigger length, which you could measure in centimetres. If A is a length, then A squared is an area, centimetres squared. And we can't add up a length and an area, so it doesn't make sense. Here's a GCSE style question for you to try. Please pause the video now and have a go, and when you're ready for the answers, press play. Here are the answers. The first question, the formula should represent a length. In B, we should have an area, and you might be wondering why. Well, that's because you have a number, so just half, times A plus B in brackets, which is a length, times by H, which is a length. So you have a number times a length times a length. Length times length is area. Number times area is area. In C, we have none of these because you are trying to add an area and a length, which you're not allowed to do. And then lastly, in D, 4/3 pi is a number, r cubed is a volume, so we have a volume.